Okay, welcome to today's lesson. Today's lesson actually comes from the Algebra 1 curriculum, though Algebra 1 courses generally don't get to this in their curriculum. So since it is a standard, we end up teaching this Algebra 1 concept actually in Algebra 2. So that's why there's no like number to this. It's not 1 point whatever. It actually comes from Algebra 1. So when you're doing your homework in this later, you will want to switch your big ideas over to the Algebra 1 textbook to access the homework. Today's lesson is all about absolute value equations and absolute value inequalities. Absolute value equations are generally fairly easy to understand and usually don't run into too many issues. But absolute value inequalities can be a little bit more confusing. So we're going to walk through each type here to show you which one is, how to do each one. So the first thing we're going to go over is absolute value equations. Now there's two types. There's one where you just have a single absolute value equaling some number. And then down here where you have an absolute value equaling another absolute value. Well, don't worry, they are both solved very similarly, and so usually there's not too many issues with this. First of all, we have to remember something about absolute values. First of all, anything in this absolute value has to turn out a positive number. So C has to be a positive number, or I guess it could be 0 too, but it cannot be negative because there's no way, if you remember anything about absolute values like in Algebra 1 or grade school, absolute values turn everything positive, so the answer to an absolute value can never be negative. So if you end up with a negative number over here, then there is not going to be any solutions. So you'll see here, if your C is less than 0, then there would be no solutions because you can't have a negative number for absolute value. So first off, this value should always be positive, or I guess equal to 0 as well. If that is the case, what you're going to want to do, because whatever is in here inside here can be positive or negative, we have to set each of these equal to a positive answer and equal to a negative answer. Now, you might be thinking like, well, wait a minute, you said it can't be a negative. Yes, the answer cannot be negative, but what's in here can be positive or negative. Like if this is -5, then I know I get 5. But if this is +5, I also get 5. So we have to set the inside of the absolute value equal to a positive number and a negative number, because the answer could be either one. When you're doing absolute values where it's one absolute value equaling another absolute value, it's exactly the same thing. You're going to set the absolute value equal to a positive version of that answer as well as a negative version of that answer. You're going to want to put them in parentheses because you do have to distribute this negative to both of these. So we're going to go over some sample problems of each one, and hopefully it makes more sense. The one thing you're going to want to make sure when you are solving these is that the absolute value is by itself. There's nothing on the outside, nothing on the outside. There's nothing over here other than the absolute value. If there is, it will need to be moved to the other side. For example, this one has a 2 on the outside, so that's got to go. This one's got a 3 and a -5. These are going to have to go to the other side before I do this first step. If the absolute value is isolated and it's all by itself, we can go right to solving this by simply just saying, okay, well, then 3x plus 12 equals, in this case, it's 0. There is no positive 0 and it's a -0. It's just 0. In this case, I'm only going to get one answer because the answer is 0. There's no positive or negative here. So I just solve it like a regular equation. I'm going to subtract the 12 and get 3x equals -12, and then divide by 3, and get x equals -4. And so in this case, I only get one answer because it was equal to 0. Moving on to number 2, again, sometimes it does that. So I do have to isolate this absolute value. So this 2 that's on the outside is going to need to be moved to the other side. So we do that by simply dividing both sides by 2. And so now I have x plus 2 and the absolute value equals 4. Now that the absolute value is isolated, I can set it equal to a positive version and a negative version. So this is going to split up into x plus 2 equals a positive 4 and an x plus 2 equals a negative 4. Because both answers are correct, if both of them get a positive or negative 4, then the absolute value would be 4. And then you just solve each one. This could be either one, so we put an or there because it could be either or. When I solve here and subtract the 2, I get x equals 2. Or x could also, also be x equals negative 6. So either one would work. One or the other would work. And you could check it. I mean, I could put negative 6 into here. Negative 6 plus 2 is negative 4. The absolute value of negative 4 is positive 4, and 2 times 4 would be 8. But also, I could put a 2 in here. 2 plus 2 is 4. The absolute value of 4 is, well, 4, and then 2 times 4 is 8. So both of them actually work. Here, again, we're going to need to isolate the absolute value. So everything that's on the outside is going to need to go to the other side. We start here. I'm going to add the 5. You always start by moving the adding and subtracting one over first. So now I have 3 absolute value. 3x plus 12 equals 15. Then I can divide by the 3, giving me absolute value of 3x plus 12 equals 5. Excuse me. So you can see here inside that I've isolated the absolute value. So now I can set it to a positive version of this and negative version. So this is going to split off into a 3x plus 12 equals positive 5, or a 3x plus 12 equals negative 5. And so we solve. Okay, subtract the 12. Okay, I got 3, x equals, 5 minus 12 is going to be negative 7. So I end up with, over here, just negative 7/3. And then on this side, I'm going to also subtract 12, but in this case, I get negative 17. And then when I divide, I get x equals negative 17 over 3. And so you'll see in the most cases, you'll get 2 answers unless your absolute value equaled 0. So that's how you do it. I mean, I can do, so a couple things are going to happen here. So I wanted to show you one problem here where we get something weird happen here. So if I'm trying to do this and I'm trying to isolate the absolute value, and I divide by negative 4, what happens here is I get 3x plus 12 equals negative 4, the absolute value. Now here's where we need to recognize, like, hey, wait a minute. Whatever is inside here cannot equal a negative number. There's nothing I can take the absolute value of and it come out to a negative number. So right away, I don't need to do anything. Right now, I already know that this is no solution. Nothing will work here to give me a negative 4. It's not possible. So you can do that. The other questions here are going to be absolute value versus an absolute value. So again, you treat it the same as the other one. The only thing you got to be careful with, I'm going to set this up as 20x equals the positive version of 4x plus 16. But it could also be 20, that's 20x could equal. And remember, with this, you're going to want to use a negative and use parentheses when you do this, because that negative will have to be distributed to both of those. On the left-hand side here, I'll just solve for x. When I subtract 4x to the other side, I get 16x equals 16. Okay, well, that's pretty easy. X equals 1. On this side, I have to distribute that, so I get 20x equals negative 4x and negative 16. Now I actually have to add 4x. So I get 24x equals negative 16, divide by 24. And so I get x is negative 16 over 24, or you could reduce that to negative 2/3. And that's how you do those. So the same thing would happen in number 6. I'm not going to do number 6, but the same thing would happen. You would have 4x plus 9 equaling the positive version of 2x minus 1, or you would have the 4x plus 9 equaling the negative parentheses 2x minus 1. And just don't forget to distribute that negative in here and then solve. So again, 2 answers. Those seem to be relatively easy. I'm not going to say that they're easy for everyone, but relatively okay for most kids. Moving on to inequalities, this is where things get a little bit more confusing here. So with inequalities, you have the same absolute value, but you don't have an equal sign anymore. You have a greater than or less than, or greater than or equal to, less than or equal to. Same thing happens here. We cannot have a C value that is less than 0. A C value, remember, absolute values cannot be anything negative. So if you have a negative number here, there is no solution. The number that's over here always has to be greater than 0 for there to be any solution. The only thing that gets weird here is you have answers that have this and answers that have or. When you are doing and or, the way that you always remember it, and the way that I always remember it, is look at the inequality. Less than would be a conjointed inequality. You don't really need to know what conjointed means, but you can probably figure out that conjointed means that they would be together. So this would be your and. And the way I always remember it is the inequality that's less than kind of looks like a C. See, less than is C. So I always remember less than looks like a C, so this is conjointed, so I know that this would be and. Whereas a greater than symbol does not look like a C. A greater than would be disjointed. You can probably guess that disjointed means that they are apart, and that's why you have or they're separate here as opposed to and being together. That's the way I always remember it. Less than looks like a C, so conjointed, so they're together, so that's and. Disjointed, so or, they would be separate. And that's how I remember those questions, and so that's how we answer this. Okay, so when we go to solve these, again, you're going to look at this, and again, just like the equations, you're going to set them to negative values as well as positive values, and you want to make sure that you are flipping the inequality sign as well. So notice how, like, when you have a negative version, it's going to be greater than a negative version and less than the positive version. Notice how the inequality sign flips for each one of these. Okay, so it's less than the positive, but then the negative. Notice the inequality sign flips. So you're always going to have opposite inequality signs. Even down here, when you have greater than C, the less than negative C, it flips. The inequality flips. So I'll show you here what that looks like. So I need to have one that equals a positive version as well as a negative version. Now this is, can you guess? Is that going to be an and or an or? Well, the less than symbol kind of looks like a C. So this would be conjointed, so this would be and. So I can say that x plus 2 is less than 8 and x plus 2, don't forget to flip the inequality sign, is greater than negative 2. Oh, negative 2. Why did I do that? Negative 8. Sorry. It's not negative 2. It's negative 8. Notice how I made a positive version and a negative version. The inequality sign stays the same, but when I do the other one, the inequality sign as well as the sign are opposite. This is now greater than. And then you go ahead and solve it just like you would any other inequality or equation. So I subtract 2. There we go. X is less than, looks like 6. And x, when I subtract 2 over here, x is greater than negative 10. And that would be your answer. Same thing happens here. I do need to isolate the absolute value, so all these things are going to need to be moved over first. Subtract 10. Okay, subtract 10. So I have 3, absolute value 2x plus 5 is less than or equal to 27. Then I divide by the 3. So I have the absolute value of 2x plus 5 is less than or equal to 9. So again, we look at this inequality. It is a less than, even though it's a less than or equal to, it's the same thing. This looks kind of like a C. Okay, so this is going to be an and one, not an or. So when we do this, we have 2x plus 5 is less than or equal to 9, and 2x plus 5, don't forget to flip the sign when you do the negative version. And then you solve. Okay, and so that's, I'm not going to do that again. You guys can kind of get the idea there. So here, this is a reason why I want to show you this one is because when we do this, subtract 5, negative 2, x minus 3, greater than or equal to 6. And then when we divide by the negative 2, we have the absolute value of x minus 3 is greater than or equal to negative 3. Now here's a problem, obviously. We cannot have, I take it back. You can have, this is one of those weird ones. So I can have numbers that are greater than negative 3. I can't have, they have to be numbers that produce it to be a positive number, but I can get numbers that are greater than negative 3. It's just, it can't be negative here. So we're going to solve this and go through here. We just can't have anything that would be less than this. There are no numbers that produce, because greater than, just something to understand here, greater than is anything greater than negative 3. Now, can negative 3 be the answer? No. Can negative 2? No. Can negative 1? No. But 0 can, and 1 and 2 and 3 and so on can. So there are answers that do produce a valid solution that is greater than negative 3. So I'm going to go ahead and do this. So I have x minus 3. That's not a 3. X minus 3 is going to be greater than or equal to the negative 3. Since this is this does not look like a C, this is going to be or. And then I have or absolute value of x minus 3 will be less than, don't forget to flip the sign when you do the opposite version. In this case, oh, what am I doing? There's no absolute value bars anymore. There you go. Solve. X is greater than or equal to, when I add the 3 over, I get 0. Here, when I add the 3 over, or x is less than or equal to, when I add the 3, I get 6. Now, when we look at these answers, we do have to check and make sure that these answers are okay. Because we're working with a negative number, we do have to make sure that these answers do work. So when we look at greater than or equal to 0, is this true? Well, if I put in 0 for x, 0 minus 3 is negative 3. Negative 3, the absolute value is 3. Is 3 greater than or equal to negative 3? Yes, it sure is. Here, when I do 6, less than or equal to 6, so if I use 6, I can have 6 minus 3 is 3. 3 is 3. Is this greater than, is that greater than or equal to negative 3? Yes, it is. So both of those answers work. And that's pretty much how it goes all the way through here. I'm trying to see if there's anything that's weird. This number 6. Probably want to do number 6 here. So this is a situation where I need to isolate the absolute value. So we're going to move everything across. Change it back to red. When I add 3, I get add 3, negative 3, absolute value of x minus 1 is less than or equal to negative 18. Divide by negative 3. I guess this works out too. I didn't think that it did, but x minus 1 less than or equal to, and then 6, and then you can solve those, split those off into one equaling a positive 6, or less than or equal to a positive 6, and then greater than or equal to a negative 6. I was trying to see here. I thought there was one. This one you're going to get 0. If you try to do it, you'll get 0, which means there will only be one solution. I don't see anything else that comes up with some weird no solution thing, but that should be it. Okay, I'm not going to do all those problems. It's all pretty much the same thing. Just remember that if it is less than, looks like a C, it's conjointed. That means and. If it's greater than, it does not look like a C, so it's disjointed, and it's the or version, because those will be graded on there. So, all right, that's outcomes 3 and 4. Thanks for watching.